It was the early 1970s, a time when the world was split into two big sides. On one side was America and its friends. On the other side was the Soviet Union and its friends. Both sides had many secrets and watched each other closely. In the Soviet Union, a group of very smart scientists worked in a secret building. They were beaming with pride. They had just launched a new satellite into space, a special kind of eye looking down at Earth. This satellite could see things no other Soviet machine had seen before. The scientists gathered around large screens, watching blurry but exciting images. They saw ships moving on the ocean and planes flying high in the sky. Their new satellite was like a giant spy in the sky, helping them keep track of what the other side was doing. They believed they were ahead in this race to see everything. They clapped each other on the back, feeling very clever. But soon, their excitement would turn into a big puzzle. The scientists continued to watch the blurry pictures from their satellite. At first, everything seemed normal. American ships sailed across the big oceans, and their planes flew in the sky. But after a few weeks, something strange started to happen. The American ships and planes began to move in ways that puzzled the Soviet watchers. It wasn't just where they were going, but how they were getting there. A ship would make a sharp turn in the middle of the ocean, exactly where it needed to be for a secret meeting. A plane would fly a very precise path, always hitting its target on practice runs. It was as if they knew their exact spot on Earth down to the very last foot, even in the vastness of the sea or the emptiness of the sky. This was much more accurate than anything the Soviet Union could do, even with their new satellite. The Soviet scientists scratched their heads. How could the Americans be so exact? It was like they had a magic map that showed them their exact location at all times. This mystery made the scientists forget their earlier pride. A worried whisper started to go around the room. How are they doing this? The puzzle grew bigger with each passing day. The Soviet scientists watched, fascinated and frustrated, as American naval ships navigated through rough seas without ever seeming to get lost. They would steer clear of dangerous icebergs by just a few feet, or meet up with other ships in the vast, empty ocean at the exact minute planned. Airplanes, too, flew straight and true, landing perfectly on small aircraft carriers in the middle of nowhere. It was like they had an invisible string guiding them. "They know exactly where they are," mumbled one scientist, tapping his pencil on a map. "Even in the middle of the Atlantic, where there are no landmarks, no lighthouses, nothing to tell you your precise spot." Another added, "It's not just knowing the general area. It's knowing their position down to a few meters, maybe even less." This kind of perfect navigation was a huge advantage. It meant American forces could move faster, hide better, and strike with more power. The Soviet team knew they had to figure out this secret, or they would fall far behind. The question echoed in the quiet room. How were the Americans doing it? The scientists gathered in a small, stuffy room filled with maps and glowing screens. They talked for hours, trying to guess the American secret. "It must be some new kind of navigation system," said Professor Ivanov, stroking his beard. "Something that gives them their exact spot, no matter where they are." "But what kind?" asked Dr. Petrova, tapping her pen. "They aren't using stars, that's too slow. And our old radio systems aren't nearly this good." The most common idea was that the Americans had invented a super advanced radar system. Radar uses radio waves to find objects and measure distances. Perhaps the Americans had put very powerful radar stations all over the world, or even in space. These stations would send out signals, and the ships and planes would use them to pinpoint their location. This seemed like the most logical answer. "Yes, it must be a new type of radar," Professor Ivanov agreed, nodding slowly. "They send out signals from a network of satellites or secret ground stations, and the American ships and planes pick them up. It's the only way they could be so precise." The team began to focus their efforts on finding these new radar signals. If they could find them, they could figure out how the system worked. With the idea of a new radar system firmly in their minds, the Soviet scientists set to work. They turned their best listening stations and satellites toward American activities. Huge dishes on the ground and tiny antennas in space were all tuned to pick up any unusual radio waves. They listened for strong signals, weak signals, signals that pulsed, signals that hummed, anything that might be part of a secret American navigation network. Days turned into weeks, and weeks turned into months. The scientists sat in front of their screens, watching lines wiggle and numbers flash. They analyzed every beep and every buzz in the airwaves. But no matter how hard they tried, they found nothing new. There were the usual American radio broadcasts, their normal military communications, and signals from their older navigation systems. But there was no sign of a powerful, worldwide radar system that could guide ships and planes with such perfect accuracy. The airwaves were silent regarding any secret new signals. Professor Ivanov stroked his beard again, a frown deepening on his face. "It makes no sense," he said. "If they are using radar, we should be able to hear it. The signals would have to be very strong to cover such vast distances." The team was back to square one, more baffled than ever. The frustration in the Soviet research room was thick enough to cut with a knife. Professor Ivanov paced back and forth, muttering about invisible signals. Dr. Petrova sighed, looking at stacks of graphs that showed nothing but normal radio chatter. Everyone felt stuck. Then, a quiet voice spoke up from the back of the room. It belonged to a younger scientist named Anatoly, who usually just listened. "What if we're looking for the wrong thing?" he asked. "What if it's not radio waves at all?" Everyone turned to him. Professor Ivanov raised an eyebrow. "What do you mean, Anatoly? What else could it be?" Anatoly walked to the main table, a spark in his eye. "Radio waves are one kind of energy, like sound or heat. But there's another kind of energy that travels very fast and can be very precise. What if the Americans are using light?" The room fell silent. Using light? For navigation? It seemed like a wild idea. Light travels in a straight line and is very hard to bend around the Earth. But Anatoly continued, "Not just any light, of course. What if they're using a laser?" The word laser hung in the air, a new and startling possibility. Lasers were powerful, focused beams of light. Could they be the secret? Anatoly saw the doubtful looks on the faces of the older scientists. He knew his idea sounded far-fetched, but he had been thinking about it for days. He cleared his throat and explained, "We know about radar, how it sends out radio waves and listens for them to bounce back. But there's a new technology, something even more focused than radio waves, that uses light." He paused, then said the word again with more confidence. "A laser. You know, those things that make very thin, bright beams of light." He gestured with his hands, miming a straight line cutting through the air. Unlike a regular light bulb that scatters light everywhere, a laser beam is incredibly narrow and powerful. It doesn't spread out much, even over long distances. Professor Ivanov remembered seeing reports about these new laser devices. They were used in labs for experiments, and sometimes even in factories for cutting things. But using one from space to guide a ship? That seemed like science fiction. Yet, Anatoly's point about the laser's focused power was hard to ignore. If you couldn't hear a radio signal, perhaps it was because there was no radio signal to hear. Perhaps it was a beam of invisible light doing the work instead. This new thought slowly started to change the mood in the room. Anatoly continued to explain his idea, seeing a glimmer of understanding in the eyes of his colleagues. "Imagine a laser on an American satellite," he began, drawing in the air. "It could send a super-thin beam of light straight down to a ship or plane. That light would bounce off and travel back up to the satellite." He paused for effect. "We know how fast light travels. It's always the same speed. So, if you measure the tiny bit of time it takes for the laser light to go down and come back up, you can figure out the exact distance between the satellite and the ship." He wrote a simple math problem on a blackboard. Distance equals speed of light times time, divided by 2. He then pointed to the problem. "This is what we call a laser rangefinder. It's like a very fancy tape measure that uses light instead of tape. And if you have a few satellites, each sending out these laser beams, a ship or plane could get many distance measurements. With those numbers, it could calculate its exact spot on Earth with amazing accuracy." The room was quiet again, but this time it was a quiet of deep thought, not doubt. The idea was still bold, but it now made a strange kind of sense. Even though Anatoly's explanation of a laser rangefinder made a kind of sense, many of the older scientists still shook their heads. Professor Ivanov frowned. "Anatoly, your idea is clever, but think about it. A satellite is flying hundreds of miles above Earth, moving very, very fast. And a ship or plane below is also moving." Dr. Petrova chimed in. "To hit a small target, like a ship, with a laser beam from that far away, It would be like trying to hit a fly with a tiny needle from across a football field. The satellite would have to aim perfectly, and the ship would have to stay perfectly still, which it doesn't. Another scientist added, the Earth itself is spinning. How could they account for all that movement and still hit a moving target with such a tiny beam of light? It sounds impossible. The technology to aim that precisely from space simply doesn't exist yet, not even for the Americans. They believed that while lasers were powerful, the challenge of aiming them from a fast-moving satellite to a fast-moving target was just too great. The idea was exciting, but it felt like a dream rather than a real possibility. Anatoly understood their doubts. He had thought about them himself, but he hadn't just dreamed up this idea, he had worked on it. He pulled out a roll of paper from his bag and spread it across the table. On it were detailed drawings and many lines of numbers. It's true that aiming is hard, he admitted, pointing to a drawing of a satellite. But not impossible. The satellite wouldn't just shoot blindly. It would know its own exact path and speed. It would also get a rough idea of the ship's location from other sensors, like our own spy satellites. He then showed them calculations. With powerful computers, the satellite could predict where the ship will be in the next moment. It can aim the laser not at where the ship is, but where it will be when the light arrives. It's like leading a target when you shoot an arrow. He showed how tiny adjustments could be made very quickly. The drawings showed special mirrors and gyroscopes on the satellite, designed to keep the laser steady and aimed precisely. The math, complex as it was, showed that with enough computing power and clever engineering, it could indeed work. The older scientists leaned in closer, their skepticism slowly turning into wonder. But how does the light get back to the satellite? Asked Dr. Petrova, still trying to grasp the full picture. Even if you hit the target, the light would scatter in all directions. How would the satellite see it again? Anatoly pointed to another part of his drawing. That's a very good question, Doctor. And it's where the cleverness comes in. The laser beam is very strong, but it's true that when it hits a surface, most of the light scatters away. However, some of that light, a very tiny amount, will bounce directly back towards where it came from. He explained further, the satellite wouldn't need to catch all the light, just enough of it. It would have a very sensitive sensor, like a super powerful eye, positioned right next to the laser. This sensor would be specially designed to pick up even the weakest returning light signal. Think of it like shining a flashlight at a mirror. Some light bounces off the mirror and comes right back to your eyes. The American ships and planes might even have special reflective surfaces to help the light bounce back more easily, making the system even better. The idea of a tiny, invisible beam of light traveling from space, bouncing off a moving target, and returning to its source began to seem less like magic and more like advanced science. Professor Ivanov, now fully engaged, leaned over the table. So, you're saying the secret isn't just sending the light, or even receiving a little bit back. It's about the timing. Precisely, Professor. Anatoly's eyes sparkled. Light travels incredibly fast, but it still takes time to go from the satellite to Earth and back. We know the speed of light exactly. If you have a super accurate clock on the satellite, one that can measure tiny fractions of a second, you can measure how long the light takes for its round trip. He pointed to the math equation he had written earlier. Once you have that travel time, you just multiply it by the speed of light, and then divide by 2 because the light traveled down and then back up. That gives you the exact distance between the satellite and the object below. And if you have multiple satellites, Dr. Petrova mused, each taking these distance measurements at the same time, a ship could use those numbers to figure out its own position in 3 dimensions. How far north, how far east, and even how high or low it is. The room hummed with a new energy. This was not just a clever guess. It was a workable plan, backed by physics and mathematics. The pieces of the American puzzle were finally starting to fit together. The room was no longer filled with doubt, but with a growing sense of alarm. Professor Ivanov looked at the calculations on the blackboard, then at the maps showing American ships moving with pinpoint accuracy. If this is true, he said slowly, if they can really measure distances with such lasers, then their navigation is far, far better than anything we have. Dr. Petrova nodded grimly. Our best systems can tell a ship its position within a few hundred meters, sometimes even a kilometer in the middle of the ocean. But what Anatoly is describing, that would be accurate down to a few meters, perhaps even less. Imagine knowing your exact spot on Earth with the precision of standing in your own backyard. This difference was huge. It meant American submarines could hide better, knowing their precise depth and location. It meant their planes could hit targets with greater certainty. Their entire military could operate with a level of confidence and speed that the Soviets could only dream of. The technological gap was not just a small step, it was a giant leap. The Soviet Union, which prided itself on its scientific might, was suddenly far behind. The realization was sobering, and a quiet urgency filled the room. They had to catch up, and fast. The urgent discussions among Professor Ivanov's team quickly reached the highest levels of the Soviet government. It was a serious matter to admit that the Americans might have such a huge technological lead. At first, there was resistance. Some high-ranking officials found Anatoly's laser from space idea too unbelievable, like something from a children's story. They preferred to stick to the old ideas of radar. But Professor Ivanov, Dr. Petrova, and Anatoly argued strongly. They showed the detailed calculations, the drawings, and the evidence of America's baffling precision. They explained that if the Soviets ignored this possibility, they risked falling even further behind. The argument was strong enough that, after many long meetings, the Soviet leaders finally agreed. They understood the danger of not knowing, and the even greater danger of being outsmarted. A secret project was quickly started. It was given a code name that only a few people knew. Its mission was clear: to study Anatoly's laser rangefinder idea and see if the Soviet Union could build its own version. Anatoly, the young scientist who had the crazy idea, was put in charge of a special team. The race to catch up had officially begun, hidden from the eyes of the world. With the government's approval, Anatoly's team plunged into the challenging work of building their own space-based laser rangefinder. They quickly learned that what looked good on paper was incredibly hard to make real. The first problem was the laser itself. It needed to be powerful enough to send a beam all the way from space to Earth, yet small enough to fit on a satellite. They worked day and night in special labs, trying different materials and designs. Then came the aiming system. Anatoly's drawings showed how it could be done, but actually building tiny, super-fast mirrors and gyroscopes that could move with such perfect accuracy was a nightmare. Even the smallest vibration could throw the beam off by miles. The engineers struggled to make parts that were both strong and light, and that could work in the cold, harsh environment of space. And the clock. To measure the distance precisely, they needed a clock that was unbelievably accurate, far better than any clock they had ever put on a satellite before. Every tiny error in time measurement meant a huge error in distance. The team faced one setback after another. It was a frustrating and slow process, proving just how difficult it was to master this cutting-edge technology. The challenge of building their own laser rangefinder system was truly immense. Anatoly's team faced a triple threat of problems. First, there was the laser itself. They needed a laser that was not only powerful enough to punch through Earth's atmosphere from space, but also small and tough enough to survive a rocket launch in the harsh conditions of orbit. Making such a device was a constant battle of trial and error, with many lasers burning out or simply not being strong enough. Second, the aiming. Even with Anatoly's clever math, building the actual parts to point the laser with pinpoint accuracy was a huge hurdle. Tiny mirrors had to swivel faster than the blink of an eye, guided by super-precise computer programs. Any wobble, any tiny mistake in aim, and the laser would miss its target by miles. It was like trying to thread a needle from a speeding train. Third, and perhaps most frustrating, was catching the returning light. Even if the laser hit the target, the tiny amount of light that bounced back was incredibly faint. The satellite sensor had to be incredibly sensitive, able to pick out a single photon of light from all the glare of the sun and the reflections from Earth. It was like trying to hear a whisper in the middle of a thunderstorm. Each of these problems seemed almost impossible to solve. While Anatoly and his team wrestled with the complex problems of building their own laser rangefinders, the American military continued its impressive, almost magical navigation. Soviet spy satellites still watched, and the images confirmed that American ships and planes were not just lucky. They were consistently and flawlessly precise. A submarine would surface in the exact spot planned for a rendezvous, even after weeks underwater. Aircraft would fly complex routes over featureless deserts or vast oceans, always hitting their targets on practice bombing runs with incredible accuracy. There were no more accidental detours or missed appointments for American forces. They operated with a silent confidence that spoke volumes. This continued accuracy was a constant reminder to the Soviet scientists of how far behind they were. It fueled their frustration, but also their determination. Every new report of American precision made Anatoly's theory seem more likely and the need for their own working system more urgent. The American advantage was not a fleeting trick. It was a deeply integrated capability that gave them a clear edge in the global game of hide-and-seek. The puzzle remained, but the pieces were slowly revealing themselves. The Soviet leaders grew impatient with the slow progress on their own laser rangefinder. They needed proof, some solid evidence that Anatoly's theory was correct. If the Americans were using lasers, there had to be some physical signs on their ships and planes. Spy planes were the best way to get a closer look. Orders went out to special Soviet spy planes. Their pilots were told to fly very close to American ships, closer than they normally would dare. They had to take many pictures and watch for anything unusual. These planes, equipped with powerful cameras and special sensors, would swoop low over American aircraft carriers and destroyers, trying to spot any strange equipment that might be related to laser navigation. The pilots were looking for anything that didn't look like a normal antenna or radar dish. They were specifically told to look for smooth, shiny surfaces or odd glass-like panels that might be used to reflect laser light. It was a risky job, flying so close to enemy vessels, but the need for information was critical. The hope was that these close-up observations would finally confirm what Anatoly's team had only guessed at in their labs. They needed to see what the Americans were really hiding. The Soviet spy plane pilots flew their dangerous missions. They came back with rolls of film and detailed reports. The scientists eagerly examined the high-resolution photographs, zooming in on every part of the American ships. At first, they saw nothing out of the ordinary, just antennas and radars they already knew about. Then, one day, a young analyst working with Anatoly shouted. He pointed to a small, flat panel on the side of an American destroyer. It wasn't a window, and it wasn't a sensor they recognized. It was too smooth, too perfectly flat, and seemed to be made of a special kind of glass or crystal. It looked exactly like a reflector, designed to send light straight back to its source. "Look," he exclaimed. "And here, on the top of that aircraft carrier. Another one, smaller, but just as smooth." The pictures showed several of these strange, mirror-like panels in different places on various American vessels. They weren't big or flashy, designed to be easily missed. But to the trained eyes of the Soviet scientists, they were unmistakable. These were not for radar. These were for reflecting light. Anatoly's theory was no longer just a theory. The Americans had indeed put special equipment on their ships to work with something sending light from above. The discovery of the strange, mirror-like panels on American ships sent a jolt of excitement through the Soviet research facility. Professor Ivanov, who had been skeptical at first, now looked at Anatoly with a mix of awe and worry. "Anatoly, you were right," he said, his voice quiet but firm. "These are not for radar. These are for reflecting light. Your theory, it is confirmed." Dr. Petrova stared at the photographs. Her earlier doubts completely vanished. "They are using lasers from space," she whispered. "The Americans have built a system that sends laser beams from satellites, measures the time it takes for the light to bounce off these reflectors, and then calculates their precise location. It's brilliant, and it's exactly what we couldn't detect with our radio listeners." The room buzzed with newfound understanding. The baffling precision of American ships and planes, the silence on the radio waves, the seemingly impossible accuracy, it all made perfect sense now. The pieces of the puzzle clicked into place. The Soviet scientists were no longer baffled. They were enlightened, but also deeply concerned. The Americans had a secret weapon, an invisible eye in the sky, that gave them an undeniable edge. The race to catch up became even more urgent, now that they knew exactly what they were chasing. With the truth now undeniable, the Soviet project to build their own laser rangefinders got a massive boost. The frustrating setbacks didn't disappear, but the scientists and engineers, now knowing exactly what they were aiming for, redoubled their efforts. They worked longer hours, pushed materials to their limits, and came up with clever new ways to solve problems. "Anatoly, Now a hero in the lab, guided his team. They didn't just try to copy the Americans. They dug deeper into the science of light and space. They learned more about how to make lasers incredibly powerful and stable. They studied how light travels through Earth's atmosphere, learning how to account for clouds and dust that could weaken the laser beam. They became experts in making tiny, precise instruments that could aim a laser from a fast-moving satellite and catch the faintest returning glimmers of light. This intense effort wasn't just about building a single device. It was about advancing Soviet science and technology across the board. The need to catch up with America's laser rangefinders pushed them to invent new types of optics, better computers, and more accurate clocks. They were learning at an incredible pace, slowly closing the gap that had once seemed impossibly wide. The journey to understand America's laser rangefinders had been long and full of twists. From initial bafflement to Anatoly's bold guess, and finally to the undeniable proof from spy planes, the Soviet scientists had come full circle. They now fully understood the American secret. Precise navigation was being achieved by lasers from space, bouncing off reflectors on ships and planes. This understanding brought with it a mix of awe for American ingenuity and a strong sense of urgency. Professor Ivanov looked at his team, their faces tired but triumphant. "We now know what they are doing," he stated, "and we know how far we must go." The challenge was clear. The Soviets needed to work even harder, not just to copy, but to innovate and push the boundaries of their own technology. The story of the baffled Soviet scientists ended not with defeat, but with a renewed commitment to scientific progress. They realized that in the fast-paced world of technology, staying ahead meant constant learning and endless effort. They understood that the future belonged to those who could dream up the next big idea and then work tirelessly to make it real. The race was on, and the Soviets were now running with a clear goal in sight, determined to master the secrets of light and space.